You'll probably see this in my other video. I'm gonna have to edit it so that the 20-minute long video is shorter. So, as I was saying, these are specific functions, but they're left in terms of only one variable when, wait, hold on. I know I'm using implicit differentiation here. Oh, well, for the first problem, it's only in terms of one variable, so I guess one doesn't necessarily see the effect of the implicit differentiation, but you must remember, well, I guess one can remember that when you're taking the derivative of g of x, you also have a dx over dx, which for the sake of simplicity equals 1. However, when you start interacting with functions where there are two variables, x and y, or y and z, or x and z, then you start to see the place of the differential, or the, what's it called, difference quotient as well. The place of the differential and the difference quotient from the dx and dy. Basically, you start to see the influence of the second variable within the function, and how in some cases it isn't always possible to tell whether or not one can acquire the differential, the function from the information given. So you can't always get an explicit function, like you can't always get a y of x from this equation, and that accounts for perfect shapes, such as a perfect circle, which is a circle with a radius that's, well, it means it has no eccentricity, basically. There's no elliptical stretching, there's no there's squeezing either. So that displays mathematically how that functions. Honestly, my intention is not to show my work, as in like show other people how to do it. It's just to confirm exactly what I'm saying. Hold on, let me show you what it looks like in the textbook, though, or my textbook. Anyways. That's my textbook. Ugh, still kind of bothering me a little. Oh, yeah, see, when I get into doing math and stuff for fun, then I start sketching and stuff like this, and I guess it's a focus thing. And I remember my high school teacher, Mr. Brescher, he taught me that I don't know, some people do other things to concentrate before a difficult task, even after studying a lot. And honestly, I was doing that for a long time and not realizing what that was called. Anyways. Is it here? Oh, wait, hold on. check the date. That's from this summer. Yeah, so I guess that's usually my problem. I start reviewing to prepare, and then I get so into my work that it literally changes my personality. And yeah, that's the thing. So, you know, related rates. Oh, yeah. Yeah, that's the one thing from BC Calc that I never mastered. I mean, he taught it over and over to me again, and he said there was a reduction in the use of it. However, I guess I'm kind of obsessive in the fact that I like to consume as much information as possible, even when I have a mastery of everything else. Like, I don't know. It's just something about me. I guess that's where I usually tend to get in trouble for doing things myself. But yeah, like for example, with my senior project, I almost didn't graduate on time because of I don't know. I was trying to fix it all by myself. The process of setting up the I don't know, setting up the whatchamacallit. Basically, I was given a way to just not do the senior project, do like 5 to 10 hours, and then not do anything else, and I couldn't deal with that. So I literally complained until they let me do something. So yeah. Oh no, that's too far. Proper niggles, integration by parts, fluid force, and arc length. Oh, here we go. Ooh, cool. Saturn. Hey, that's a page. What? 477. So I'm pretty sure it always had something to do with perfect geometry, anyways. So I started seeing that in my mind where, yeah, it had to do with perfect geometry, even when I was just doing straight up math. And yeah, so let's see. Comparison. Pontoon. No. I don't know. Yeah, I like dedications like this, but my favorite ones are, I guess, Savante or Hinius, and it's a lot bigger, so. But that's just as respectable. Oh, here we go. That's something like what I'm doing. Differential equations, growth and decay models. Here we go. Newton's law of cooling. Newton's law of cooling. Which has an application for forensic science. Oh gosh. Yeah, this is when I knew something was up with me, because it wasn't that I was able to do three, the problem a bunch of different ways, uh, but it was that I was seeing those different ways in a matter of minutes, if not seconds. Like, for example, uh, yes, for the first attempt, I think I started off the problem and I couldn't figure it out. And then, I don't know, after 2 or 3 days of just, I don't want to say just thinking about it, but uh, trying to rearrange the variables so I had to use Newton's law or for cooling and Newton's cooling bodies. I did it the initial way I was taught, I guess. And then I saw an application for, I don't know, the ideal gas constant. And I don't know. So, yeah, I'm like 1, 2, 3 ways. I don't know if the application I used is 100% correct in that it correlates exactly with the way the physics of the ideal gas law works. So, for example, like when I think I posted the picture of a screenshot of something that said electrons don't emit photons, and I never made the assumption that they did. However, I get I guess there's an assumption that I was somehow making that assumption in what I was saying, or something quite close. However, I was just using ethical logic to do the best I could to find things that already existed that worked with the theoretical values and numbers that I was getting and what was being implied to me from the science, the side channel episodes that I saw. So, like, for the documentary series, How the Universe Works, Outrageous Acts of Science, the one where they modern marvels of science, and maybe one more. I also like when I would see something that's very close to something I was working on the same week, I would check the weather. The weather channel, which is, well, the science channel is 622. The weather channel is 619. The history channel, I don't know if it's the international one or not, is the next channel, and I usually flip between 10, 10 to 15 channels to see if, I don't know, I guess I'm doing something unethical or my science and math are off in a way that would be destructive or straight up embarrassing to someone. I don't know. Because honestly, for me, I don't know. I guess I'm apathetic most of the time. So I wouldn't care, but I don't want to embarrass or hurt anyone from just accepting punishment from others. Okay, I gotta go. It's almost 15 minutes. So, yeah.